Hello everyone, in this presentation we will show the paper Control of Manufacturing Systems by HMS IPS Paradigms orchestrating I4.0 Components based on capabilities. My name is Jackson Veiga from Polytechnic School in the University of São Paulo. This presentation will be fragmented in 7 sections: introduction, relationship with artificial intelligence systems, bibliographic review, proposal framework, results, final comments, and the future works. In traditional industry, the engineering tasks are systematized according to real applications. The planning stage relates the features with functionalities. This means linking resource skills with specified service. After the detailing step, the processes are described following a sequence of predetermined abilities in the real resource. Therefore, engineers validate these services, specify components, and assembly them on the shop floor. However, plans are established following the guidelines of the engineering specification. If unpredictability occurs during the process life cycle, such as equipment unavailability or failure, all the plan must be remade. This means that the traditional context link resource competence to work order. However, this does not meet to the I4.0 context. The digital transformation outcomes enable the implementation of the intelligent factory. This work is supported by the context of Industry 4.0. Initiatives like RAMI 4.0 with AAS to represent virtual resource and capabilities engineering has motivated this work research. Therefore, this work intends to minimize the gap between emerging manufacturing solutions and smart manufacturing concepts. Further, RAMI 4.0 guidelines are used with described AAS or Asset Administration Shell models, considering the concept of capabilities in I4.0C. The implementation of the control and the relationship of resource skills was proposed through multi-agent concept using Olonic manufacturing systems and evolvable production systems paradigms that design a framework to control and optimize coalition resource or skills. This work uses the concept of multi-agent systems, being intelligent entities that have their own reason, mass model interactions between software entities by assigning characteristics such as cooperation, coexistence, competition. Therefore, mass is described as a sub-area of AI for distributed information process. Some examples of applications that use math with AI support in the literature were smart decision tools, AI data analytics, data mining, pre-health process calculations, and equipment life estimation. One of the main features of the proposed framework was the composition of intelligent entities, that is, OLUns, describing the multi-agent system. In order to allow the relationship and ensure self-reason for cooperation of virtual assets, the multi-agent system contains OLUN supervisor, coordinates operations and evaluations, adds new competence, and checks system behavior. The nation the coalition and reconfiguration represented in the proposal outcome. Product capability OLUN, programmed to externalize generic resource capabilities. Resource OLUN, manage and negotiate with operational OLUNs the AAS resource capabilities. OLUN operational resource represents the physical resource, perceives the abilities or capabilities in the resource, have the sequence of operational events enable the execution of work orders. Describe the HMS IPS application gives the I4.0 C the capability for relationship, communication and coalition, reason and decision making. Legacy systems need to be seen by the control system, however, it must be represented in a normalized way for the context of I4.0. Therefore, an administration shell has been granted to represented work plans that contains products and these six capability fruit process. For each product described in the plan, it has its own administration shell describing the functionalities necessary for its manufacturing. Notice that capabilities can be specifically specified at a level of details chosen at the design stage. Finally, resources can be recognized by the control system from the administration shell representation of resource. This makes up the skills composition of real equipment on the shop floor. The next slide deals in more detail with the representation of an administration shell.
And distribution workstation was represented as resource administration shell. In order to access the functionalities by the control system, it was specified a standard communication submodel in the I4.0 context.
The access for each submodule containing individual skills of station resource is realized by a general submodule called capabilities that contain the submodule skills identification or IDs. Each detailed capability submodule describes specific operations such as removing base from the buffer or transporting material. The specifications described before results in this work proposal, that is a framework representing a way to migrate from traditional systems to intelligent systems in I4.0 context. This framework enables the orchestration and the reconfiguration of I4.0 C based on capability engineering. To meet the characteristics presented above, two main agents were detailed in this work: HRO, Resource Operational Column, that is specified for operation with AAS resource, having two main routines: skills and conditions. in conditions was responsible for monitor the events, expressing them about the condition of the resource. These events are treated and processed and then externalized to the respective AAS. The skills used to perform the search for resource capabilities has knowledge about skills, negotiation with other agents, and participated in coalition. Now, let's clarify some definitions achieved in this work. Coalitions means the possibility of grouping services described in the administration shell. This work more specifically description of resource capabilities. Reconfiguration means the ability of the system to organize itself in case of changes in resource or if the conditions of equipment are different from the original plan. Skills defines an agent capable of adding value to an application in the IPS paradigm or can be understood as task description in the administration shell. All supervisor is responsible for informing about the capability change, reconfigure the systems by calling other project OLUs, as well as adding or removing new agents. The main functions of this agent is OLU orchestration, execution and monitoring, capability changes, and the reconfigured application. This work proposal describes a for orchestration and reconfiguration of I4.0 C based on capabilities engineering. These systems are adequate to meet the intelligent control system specification based on HMS IPS paradigms. The integration of mass-based application can be suitable for adding intelligence to AAS virtual assets in the I4.0 context. The behavior of the system were represented through PFS diagrams respecting the characteristics of the mass projects and the guideline for I4.0. Advantages and advantages. The advantage of this structure is to enable the coalition of resources using capability-based engineering. This means changing the paradigm of traditional systems, reducing reprogramming efforts, optimizing life cycle, and meeting the demands of a connected board, characterized by distributed equipment. The disadvantage is the complexity for implementation. There are currently few use cases with real resource data in intelligent contexts. The existing use cases are not adherent to Industry 4.0 context. This work results in preliminary data for engineering proposal based on capabilities that have an intelligent structure capable of control and organizing the abilities of resource scenes as virtual entities. More experiments are needed to validate this structure, and in the future, these approaches can be unified for an ontological specification of mass in different areas of knowledge with the respective AAS from intelligent submodels. Thank you.